Hello everyone, welcome to my channel. In this video, I'll discuss about a physical chemistry practical experiment. The title of the experiment is Determination of pH of unknown strong alkali solution by color matching method. I have already made one video, in fact that was my first video about the color matching method of buffer solution. If you are interested, you can go through that video as well. Anyway, let's start. We are going to determine the pH of the solution. So first let us know what is pH. pH is defined as the negative logarithm of activity of hydrogen ion or molar concentration of hydrogen ion. That is, pH is equal to minus log of activity of H plus ion. But in dilute solution, the activity of any ion can be taken as the concentration of that ion. So in dilute solution, pH can be expressed as minus log of concentration of H plus. But here we are dealing with an alkali solution. Okay, for alkali solution, a similar term is proposed, and that term is known as pOH. So pOH can be defined as the negative logarithm of activity of hydroxide ion or molar concentration of hydroxide ion. So similar to pH, in dilute solution, pOH can be expressed as minus log of concentration of OH minus ion. Now, in aqueous medium, the sum of pH and pOH is equal to 14. This relation can be proved by considering the ionic product of water. Okay? So, if anybody knows about the value of pH of the medium, he or she can determine the pOH or vice versa. This relation we will use later. Now, you concentrate on the title of the experiment. We are going to determine by color matching method. So we have to use an indicator. And as we are dealing with a alkali solution, we have to use the acid base indicator. So let us know what is an acid base indicator. These are the mostly weak organic acids or bases which change their color remarkably with the change of pH of the medium. And in this experiment, we will use phenolphthalein as the acid base indicator. Let us see the structure of phenolphthalein indicator. At the left hand side, the structure of the phenolphthalein indicator is shown in the acidic medium. Okay, and when the pH of the medium goes higher, there are some structural changes occur, and the solution becomes pink. And these properties of phenolphthalein will be used in this experiment. Okay, these are the background of this practical experiment. Now let us know how we can actually perform the experiment in the laboratory. For this, we need to prepare 5 solutions of different concentrations. What are those concentrations? First one is the 10 to the power minus 1 normal or 0.1 normal, and the last one is the 10 to the power minus 5 normal. Any which is a strong base. So whatever the concentration are written here, we can directly use that concentration for the hydroxide ion concentration as well, because it will be 100% dissociated in the solution. So if we make a table for this solution, then for 10 to the power minus 1 normal solution, pH of the medium will be 1. And from the earlier relation, that is pH plus pOH equal to 14, we can determine the pH as 13 for the first solution. In this way, for the last solution, the pOH will be 5 and the pH will be 9. Now, how we can prepare these solutions? NaOH is a secondary standard solution. So, for preparation of exact concentration of NaOH solution, we have to take help of a primary standard solution. And in this purpose, we will use oxalic acid solution as the primary standard. Now suppose we want to prepare 100 milliliter of 0.1 normal oxalic acid solution. The basicity of oxalic acid is 2 because there are 2 replaceable hydrogens are there, and the commercial available oxalic acid have two molecules of water of crystallization. So the molecular weight is 126. That is, the equivalent weight of oxalic acid will be 63. So for 100 milliliter of 0.1 normal oxalic acid, we have to take 630 milligram of solid oxalic acid. So what we have to do, we have to take exact 630 milligram of oxalic acid, solid oxalic acid. If you have digital balance in your laboratory, you can easily take this amount, and then you take it in the volumetric flask and fill up the 100 milliliter volumetric flask with water, okay, up to the mark. Then you will get the exact 0.1 normal oxalic acid solution. Next is the preparation of about 0.1 normal NaOH solution. Why it is about? As I said, NaOH is a secondary standard, so we cannot prepare the exact NaOH solution by weighing. We have to standardize. Anyway, so for NaOH, there is only one hydroxide ion is there, so the equivalent weight and molecular weight will be same, and the molecular weight is 40. So for preparation of about 0.1 normal NaOH solution, we have to take 400 milligram of solid NaOH. NaOH is available as a pellets or bead, so you have to weigh that amount, but we will take little bit of excess of sodium hydroxide because NaOH is hygroscopic. Okay, that's why it is secondary standard. And so if we take 400 milligram, maybe that amount is not present there. So what we will do, we will take little bit of excess of 400 milligram, maybe 450 milligram. Okay, so then we will standardize this solution using the prepared oxalic acid solution. This is one of my students' data from last year. What he did, he took 25 milliliter of oxalic acid solution, prepared oxalic acid solution of strength 0.1 normal in the conical, and added few drops of phenolphthalein indicator, and in the burette sodium hydroxide solution was taken, and he got the data of 18.4 milliliter as the average value of sodium hydroxide. Okay, so if we do the calculation, what we will get by using V1S1 equal to V2S2 formula, we will get that the strength of the prepared sodium hydroxide solution is 0.136 normal. So we are trying to prepare about 0.1 normal, but the exact concentration of the sodium hydroxide solution is 0.136 normal. Now from this solution, we will prepare the exact 0.1 normal sodium hydroxide solution by dilution. So again we will do the V1S1 equal to V2S2 calculation, and we are trying to prepare 20 milliliter exact 0.1 normal sodium hydroxide solution. So that is in the left side, and in the right side the concentration of the 0.136, that is standardized value. So V2 is giving as 14.7 milliliter. So what we will do, we will take 14.7 milliliter of prepared sodium hydroxide solution, and we will add 5.3 milliliter of water to get the 20 milliliter exact 0.1 normal NaOH solution. Okay, now we will use this sodium hydroxide solution of exact strength of 0.1 normal to prepare the other solutions. How? Let us see. We will take 2 milliliter of 0.1 normal sodium hydroxide solution and we will add 18 milliliter of water. Means total volume will be 20 milliliter. So we are diluting 10 times from 2 to 20. So what will give? It will be the concentration will be 10 times diluted. So from 0.1 we will get 0.1 normal 20 milliliter sodium hydroxide solution. In this way we will prepare the 20 milliliter 0.001 normal sodium hydroxide solution by using 0.01 normal sodium hydroxide solution, and again we will prepare 0.0001 and finally 0.00001 normal sodium hydroxide solution, that is the 10 to the power minus 5 normal sodium hydroxide solution. Okay, now we have prepared all the solutions of exact concentration. Then what we will do, we will take 5 clean test tubes of similar size, means the length and diameter should be similar, otherwise there will be problem with the color gradient. Now, what we will do, we will pour 10 milliliter of the prepared solutions in each test tube and we will mark the concentration. Means in this way we will do. Suppose here 10 milliliter of solutions are there. So first test tube is 0.1 normal, this one 0.01 normal, and at the last 0.0001 normal. Okay. Now, what we will do, we will add 1 drop of phenolphthalein in each of the test tube solution. Once we add 1 drop of phenolphthalein in the every test tube, then some color will be generated. See this photo, it was taken by one of my students. So here the last solution is 0.1 normal and this one is the 10 to the power minus 5 normal. We cannot see the labeling, but it was actually 10 to the power minus 5 normal. So the extreme left test tube solution was unknown solution. So what he did, he added 1 drop of phenolphthalein in the unknown solution as well, and it generates some color, and it is matching with the third test tube, means it is 0.001 normal or 10 to the power minus 3 normal. So again we check the table. 10 to the power minus 3 normal solution pOH is 3 and the pH value is 11. Okay, so the provided test tube solutions pH will be 11. Okay, but sometimes there may be a confusion. Suppose you are confused with the number 3 and this 0.01 normal solution. So 0.01 normal or 10 to the power minus 2 normal solutions pOH was 2 and the pH was 12. So what we will report, 11 plus 12 divided by 2, that will be 11.5. Okay, in this way you can find the pH of the unknown solutions provided to you. Okay, this is all about this experiment. If you have any question, you can write in the comment box. I will try to answer those questions. Thank you all for watching my videos.